Okay, this is a continuation of this spreadsheet. This analysis of IRR problems, and we're going to include problems with probability of default, LGD, and all of that. Now, this is also going to illustrate the changing effects of changing discount rates. And really, that's the first thing we're doing right now. Okay, what we'll do in this case, we're going to evaluate the development stage IRR versus the other IRRs. Now, the crap of this Damorodin spreadsheet really addresses it doesn't address this horrible thing. Just so horrible. This, discount rates, and if you go to Pakistan, you're supposed to get an extra 11% discount rate. Peru, only 1% discount rate. Yeah, that's pretty nice. Philippines, 2%, not so bad. Portugal, only 1%, even though they defaulted on all that stuff. Romania, 3.3%. Rwanda, 8. Oh no. And Senegal, 6.7%. These are arbitrary Wall Street numbers that have nothing to do with any real risk. They're just pure arbitrary crap. Now, before we get into that, we're just going to talk about, well, if we go through different time periods and different stages, let me get my thoughts straight together here. Okay, let's press Shift Control 1. We have some expenditures for development, but then the probability of its success might be very low. For the first time, maybe we take a plane trip and talk about it. Have some meetings. And then we maybe do some Excel analysis, get some employees and working on it. Then we do some kind of feasibility studies, perhaps. And then we negotiate the contracts. And when we're finished negotiating the contracts, then we're going to continue with the project. There's no doubt. We're not going to cancel after that. I suppose we could put an option to cancel after that, but for now, that would be too complicated. And then from year 6 to year 20, we need the lifetime of the project, so it's project life. Let's make it a 40-year project, let's get into a whole little debate about the IRRs and the lifetime and all this. So now we can put a period number. Okay, and then when we, perhaps I'll start here. Alt EAS, and then let's do about 50, 60 periods. Okay. And then we can put our operating life, which starts, Okay. Now, I haven't really gone through the idea of this yet. Been very bad with my etiquette on the videos. Here is the deal. what kind of IRR do we need at different stages of the project? Can we compute the IRR? And at first we'll do it the IRR from the beginning. So we start with the development stage, we need a whole lot higher than 12% because we have these probabilities of not continuing. So how much does this probability of not continuing, how can we convert that into an IRR at the start date? Okay. So let's start with our construction is going to occur in year 5. So from year 6 to year 40 plus 6, that's when we're going to operate. So, and this one is greater than or equal to 6, and this one is less than or equal to 46, I hope. Shift Control R, count if, let's just make sure true. See, I missed one. Okay. Why do I always get that wrong? Okay. I should have subtracted one from the 46 one. Okay. Now, this is the cash flows. Now, instead of doing it like this, let's put an equal lookup. To do this better, we should have transposed this whole thing. 1, 2, 3, 4. Okay. Excuse me for at least 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Transpose. Shift Control Enter. We had to do one more here, one more here. See if it works again, excuse me. I don't know if this was any good. This was a waste. Excuse me. Okay. Let's write the text. So that's our cash flow. I think we should put our time period at the beginning. What a waste of your time. I hope I don't get one of those bad Oh no, I'm gonna get a bad thumbs down thing or something. Unlike. Oh no, oh no. Because I just wasted so much of your time. Shift Control P. Okay, but here's the, whenever we want a, oh great. So this is, we start with 6. Okay, and now we can put the lookup. But I did this whole thing just so we can put the lookup on this one, and then we can, I did it so we can shade the whole line. And this one. Shift Control R, and then we have our cash flows at the various stages. Here's our development stage, and then our construction stage, and it goes too far out, so we should multiply this by okay, this less than equal to. Okay. We can multiply this by the switch. Okay. And then we can get all of this. If I missed one of the last cash flows, I don't really care right now. Okay, now this is the IRR without probabilities, and we should say wrong, like that, because it doesn't mean anything, because the risks of these cash flows are so dramatically different than the risks of these cash flows. That's why the IRR doesn't work. So if we just put equal IRR, we get 15%. Let's reduce the cash flow to 15,000. Okay, let's just say we have this. Now, I guess it's good we did this. Okay, now, for me, the big problem here is going to try to just structure this. Now, in period 1, we'll put the cash flow. We have this cash flow. And then to get past period 1, let's see if this works. To get past period 1, we have a 2% stage, and maybe I'll skip up 1 minus this. We can always. So then, if we get to 2, then we spend this one. And then we have a probability of success after this one of 10%. You know, I'm sure you could have put some kind of fancier thing here. And how about we'll put a 1 minus this. So, and after the 10%, then we get to spend 100. And we get a probability of success after the 100 of 25%, which gives us the right to spend this much. And we can put maybe 1 minus this one. Maybe I'll put this one. Okay. After that one, after we spend this one, we get a probability of 60% and then minus this one. And we really only care about the positive things. I think we should have done this more consistently. Okay. Okay. So we have this one, this one, this one. You know, and we could, let's try. Now, once we have this one, then we have our cash flows up here. Okay, and we get all our cash flows, shift control. Okay. Now, when we do all of this, if we put a probability of 100% into all of these cases, we should get exactly the same IRR. I have to admit that I normally don't get that. Okay, and I'll probably make some mistakes, and I'll have to do this. Now, let's just try a discount rate with a development probability. And let's pretend that this is something like 15%. Okay? And that means I'm sorry. I should say required IRR at the COD. Okay, and that's what we're going to do to compute this one. Now, if I press Shift Control C, I'll get this. And okay, and we're going to try to get, you know, NPV of project. Okay, so if we get the IRR 15%, now we also need okay. So why don't we just and then we'll put discount rate. Now I'm not sure. Let's put this is our discount rate for the whole project. Okay. This is, I'm going to put required IRR at COD. Okay. And this we're going to look. Okay. Well, let's do this first. If we get the value at this stage, let's be careful. The value of these cash flows, and then we get 60% of getting those cash flows. So we take 60% of these, and then we go down and we get subtract this number from there, and that's our value. So let's put our value on the top, NPV, and use this discount rate, okay, which is bad. We don't even get 12%. Okay. And then, well, let's just go through this. Then we take this value, multiply it by the 60%, and add the this one. Now we're going to have to take a discount of this. We're going to have to discount all of this. And this is going to be the undiscounted, how about value. And then we take this one, and we only get 25% of that, and we add this. And then we take this value, and we take this one, and we add this one. Okay. Take this one. Yes. And finally, we get our value, which is this minus 2%. Now, I did something wrong. Just a minute. Okay, I'm still not quite there clearly, but now in this situation, when we had our value, and our value was measured at the 12%, okay, after we accounted for spending the development costs, we actually needed a 15% IRR. Okay, now I have accounted for the discounting of these. We should discount all of these values. And I think we should really, it's almost like an option kind of model. These should probably be discounted at a really low rate, the risk-free rate. We can put different options to discount them. Now, since this ultimate value okay, this shift control 7, we want to make a goal seek, and this, I'll call this final value. That's like our difference, and this is by let's see, first cash. Okay, so this is final value and first cash, and we can set a goal seek. Okay. Okay, and when we make a development goal seek, let's go to the data and what if analysis and make a goal seek and set this one to 0 by changing the first year cash flow. And kind of the answer of this whole thing then is that if you spend all this money, you actually need an 18% IRR in order to make it through these development properties and earn 12% at the COD. Okay, and since I'm not talking about demerit and risk premiums, I'm not so angry right now. I'm not going to use this silly thing, which is I'm out of money. Okay, and let's assign that macro to the mean. That's our development goal sheet. Now we're not finished because we have to evaluate the which ones are which, and before I forget this, this was difference. Okay. So this was final value. I think it was by changing the first cash or something. Of course I don't remember that. Okay. Whoops, I can't do that. Okay. First cash, final value. Did I get it right? No. Okay. So first final value, first cash. Okay. Seems to work. Alright. What that means is if we say, okay, we need a 10% at the final IRR, then I need, that means that the required IRR with development is 15%. Okay. Now, there's a little bit of a problem, is that we have to account for this value, and what discount rate should we apply to this to move it back over to this one? Okay, now I think so. Let's make this required discount rate at COD. Okay. And we'll, as usual, I'm not going to waste your time with the spinner boxes. We'll put all those spinner boxes in later. And we can put growth rates in the cash flows. We could do anything with these kind of cash flows we get. These could be the equity cash flows at the end of the day from our complicated, detailed financial model. Okay, now, so this was just simply the value at the last stage. And then okay. This is I got it wrong by one, but okay. this gonna, so this is the value at year one, okay? Now, when we take these values here, I don't know, I'm trying to think of a way to do this. Okay, we have to think about, let's just think about this a little more. So this, we move this back one, and then we just subtract this. So, and then we can keep taking the present value of this. So this NPV of this one, if we want to, I think let's just take this and let's put a discount rate in development period. And I think this should just be 2.5%. I think this should be, or maybe 1%, 1.5%. This should be a risk-free kind of rate. You do not, if you overstate it, you're gonna, it's this option value stuff, I think. Okay, so if we want to take it back one, we divide it by 1 plus the so this one, we take this one plus that one, and since all those cash flows occurred 1 year earlier, we again discount that by 1 plus the discount rate. I'm hoping I'm doing this right. Okay, and then again, this is bringing everything back always gradually. Okay, we can of course change all of this. Okay, and then okay, and by the time we've discounted this one at a time, we get back to all the way back to the present value. Okay. Okay. Okay, and now if we redo this, we need in order to get a real required 12% return, we need a 17% return. Now, just a minute. I'm gonna have to think about this for a second. Okay, in the intermediate time, I did a little bit of work. I put, different probability scenarios. So instead of just having, in this case, I have an extreme case with 100% probability of paying this, but no development costs. And you can see then, and I put this key output here, Control B, Shift Control 7, is that's the required IRR at COD with no development. Now, if we go through some different scenarios, if we have a base case development series, base case, just a minute, I thought okay, just a minute, oh, and of course we have a base case development expenditure, then we need an 18% IRR.
if instead we'd have high early development, we need 118% IRR to cover all of our development. If we have low development costs, we have different ones. High, no development, we need our basic 12% IRR assumption. That's how it's all kind of working. Let's put this back to 12% for a minute so we can keep the discount rate the same. Now the way I did this was first, I didn't know how to do it. So first let's make a really simple example. If we want a 0 NPV, we could take the NPV of the next period plus this NPV. We could of course also have a regular old NPV. And if we put equal NPV, so I don't want you to get all worried about the NPV calculation like some people do. I mean, this just gives you 0, okay, of course. But we could also get that NPV by taking the NPV of this one and then adding this one. So you bring this one today back to the end. This future one, it's the second year. It's actually just over 1 year. You bring it to today and do the same thing. Now you can do something else. You can also do that same thing we just did. And then after that, you can do it again and again and bring the NPV down to 0. Now you could also do this by taking the NPV at the discount rate. Whoops. Come on. NPV at the discount rate of the future cash flow. But then adding that, putting a plus sign on this one. And that gives us the same answer. And we should press F4. Now, then you can go to the next one and say, let's take this prior NPV and bring it back 1 year. And then let's just add the nominal cash flow. And that just gives you exactly the same result. And then you can get back to an NPV of 0. Now, the reason that's so important to do is what we're going to do is we have to bring all those NPVs back to 0, but adjust for the discount rates. So here's a case where we have, basically, it's the same case. Let's put no development expenditures. And then, in this case, we just have the IRR of 12%, which is our target IRR, and we can come up with cash flow that makes the IRR be 12. So if there's no development expenditures and no no probabilities. Now, let's say that there's 100% probability of success. Okay, but now let's put some development expenditures in. Okay, we could do the same thing, and this has the same formulas. We just take the last one, so we first start with our NPV, and then take the last NPV and divide it by 1 plus the discount rate. And I should have, well, I used the same discount rate. And why does this always go back? And then take the prior one times 1 plus the discount rate. And that brings you back to the same 100% NPV. Now, if you do that, because you spent some on the development, you need a higher IRR just to cover your development expenditures, and you get exactly the same. We get a 0 NPV here. And on this one, first of all, we take our value. This is our value. And then we take that value and divide it by 1 plus, and this time you notice I use the second discount rate below here. Ah, shit. I don't know why that does that. Okay, and then the third one, we did the same thing. It's taking the prior value, but this time when you take the prior value, you always multiply it by the percent probability. So this is the percent of success. So this time we take that one times J50, which is the probability. Then we take the value we get and adjust that by the probability and then subtract the number. So if it's 100% probability, we're okay. But then if we have our base case probability and we have lower probabilities, now this is just attached to the macro, so it just gives you a different number. Now, let me put it back to the 100% probability case. There's our 12.71 that we need right at financial close. But if we instead have the base case probability, then we need 19% at financial close because we made all these expenditures and we have this big chance of failure. These are our chance of failures. If we took the accumulated chance of failure to the beginning, we could kind of take this, whatever, it's almost, the failure rate is almost 100%. We could put the failure rate at different places. And then if we have a low development probability, now, I don't know why that is so high. Shift control, right arrow, control space bar. We need an enormous rate of return because our probability is so low to get to the last stage, and it's this one that really kills you. You have to make this big expenditure, and you better get, in order to make this big expenditure, you're only going to get a 20% chance of it. So you have to have enough value to cover all of that. And that means we need a 200% return by the time we're finished. Okay, maybe that's too extreme. If we have a high probability of development, kind of at the very end, this is the key big expenditure, then you need 22%. And what was it in the base case? In the base case, it was 19%. Uh-oh. High development probability. Why did that 1, 5, 50, 85? That was 100% case. 61, 5. I'll have to look at that. High last year's probability and then a low development probability, then we need 29%. Looks like a couple of them were kind of implausible, but you get the idea, I think. I'll review it one more time. And you could then, and perhaps in another day I'm going to do this, we could put specific dates here. And if we put enough dates here, we could leave some of these out and make a very flexible little tool to incorporate all the analysis. Of course, you need to estimate those probabilities, but once you estimate them, you can get it. So this all suggests that we, and let's put 5%. At the end, we only need 5%. Let's say that. Or no, 7%. That's maybe a little more realistic. So then we can put in our base case, and then we need 11% IRR to take account of all of the development probabilities. And if we have a little bit of a high early development, then we need 73. Just pure high development, we need 43. No development, we still have the 7%. High early development, that's what I said was so bad. Low development, we only need 9%. And if there's a higher probability, I did something wrong with that higher probability case. Okay, and I guess here's the other thing this is showing me. It's not funny. It's not funny. But it does show you that creating scenario analyses does check your work, doesn't it? Okay, and I think that's it for the development scenario. I'm going to keep moaning about Damaradan and IRRs in my next couple of ones as we go more from just the pure development stage to the to the construction stage and how the discount rates change over time. All right, enough of that one.